You must have heard about the laws of motion, or to be precise, Newton's laws of motion. They are referred to as Newton's laws because they were proposed by this man you see here. Now, Sir Isaac Newton discovered this 250 years ago. He stated three laws that describe the position and motion of an object in relation to the forces that are acting on it. So, in this lesson, we shall look at the first law and discuss the other two in subsequent lessons. An object can either be moving or it can remain at rest. Now, from our quest on moment of a force, we know that an object can remain at rest when the algebraic sum of all the forces acting on it is equal to zero. In other words, we say that the net force acting on the object is equal to zero. Now, from this illustration, we can say that even though an object is at rest, there is still a force or several forces are acting on it. However, the effect of these forces is equal to zero, and that is why the object is at rest. But what will happen if I add more force in one direction? Say, assuming I increase the force in the right direction while the others remain equal. The ball will start moving in the right direction with a velocity. Now, this is because I have applied a force in that direction that has overcome the ability of the object to remain at rest. Remember that the other forces are still acting on the ball as it is moving, but it is moving because the force in this direction is more than the others. Now, what do you think will happen if I apply a force in the forward direction? This force will change the direction of the ball. I can also change the velocity, right? Well, let's take this to the field to prove this. Assuming the ball is at rest and I kick it towards the right, the ball will start moving in the right direction with the velocity as we illustrated earlier. But if my friend Adi kicks it from the side, then he has also applied a force in that direction, and the direction of movement will change. And this force can also change the velocity of the ball. From this illustration, we can say the ball would have continued in a straight direction and velocity if Adi had not applied an external force in the other direction. So from these illustrations of the ball at rest and moving, we can say that the ball tends to either remain at rest or continue moving in one direction with the initial velocity if a different force was not applied to it. Now, this tendency of an object to naturally want to remain at rest or in motion with a velocity in a direction is what is called inertia. These were the observations that Sir Isaac Newton discovered that led to the first law of motion. Newton's first law of motion states that an object will continue to rest or move with a constant velocity unless it is acted upon by an external force. This first law describes the motion and position of an object. So let us summarize what we learned today. We learned that an object at rest is also under the influence of a force or forces. The tendency of an object to naturally want to remain at rest or in uniform motion in a straight line is what is called inertia. And finally, we learned that Newton's first law of motion states that an object will continue to rest or move with a constant velocity unless it is acted upon by an external force. Bye, guys, and I'll see you in another lesson.